Hello, this lesson is entitled 1D Motion Problems 5. So here we have a problem involving a penguin, and if we skip to the last sentence it says find his acceleration. So there's the penguin, he's on skis. In previous lessons we used the formal guess method of problem solving, and here we're going to use a little less formal method. We're simply going to identify each variable in the problem. And so we're told here that we have an initial speed of 0.65 meters per second. So that's the variable VI. At a later time, he has speed 1.9 meters per second. So that is his final speed. During this interval, the penguin travels 7.3 meters. So clearly that is a displacement. And we want to find, of course, his acceleration. So as we can see from these variables, there is no time that is given, and there is no time that is asked for. And for that reason, I call this last equation that we need for our toolbox the no time equation. You can see that time is not in the equation. So anytime you have a problem where the time isn't given and the time isn't asked for, this is a good place to start. Vf squared is equal to Vi squared plus 2 times A times delta D. Since typically I'm thinking of this penguin as moving more or less horizontally, I'm going to get rid of those vertical arrows and just use the horizontal ones. So, to find the acceleration, we now need to solve this equation for the acceleration. And we do that by subtracting Vi squared from both sides, then dividing both sides by 2 delta D. Again, make sure that you're able to solve this algebraically so that you have acceleration by itself. And now, everything else is known. We want to square the final speed, we want to square the initial speed, subtract the 2, and divide by 2, and divide by 7.3. The acceleration for this penguin over that time interval, 0.22 meters per second squared. Final thoughts on 1D Motion Problems 5. 1. Here, instead of using guess, we simply labeled the givens and unknowns right in the problem statement. 2. Our equation toolbox, what we need for the rest of 1D and 2D kinematics, is now complete. These are the 4 equations that are needed to solve any 1 or 2-dimensional kinematics problem. So, to write those down on a note card and have them handy wouldn't be a bad idea. Thanks for joining me.